Hi guys, I thought it might be useful for me to go through my own answers and talk you through where the marks are available rather than just give you an electronic copy. So, question 1. 1A is really lovely actually. We just have to simplify down both of these surds. Now you're lucky because you're allowed a calculator. But root 28, quite easy to do. Root 4 times root 7. Remember, the idea is that you want to pick out a square number, the biggest square number that you can. And that would give me 2 root 7. Root 343, I did need a calculator for this, is root 49 root 7, which simplifies down to 7 root 7. And having that in the question is a big hint as well, isn't it? So if you don't know what to try and divide it by 7 and see what you can get. So that all simplifies down to 9 root 7. And the marks, you get one method mark here for attempting to split up those roots and add them together. So splitting them up here and here and then making an attempt to add them together, even if it's not completely right, and you get an accuracy mark for the final answer there. I'm just going to delete this now so I can move on to part B. But I will put that the answer to this is 9 root 7 because I need that in part B because it says hence. So let's erase that. Lovely. And I've also erased, very cleverly of me, the answer I wrote up there. Okay, so part B. Obviously, when it says hence, I'm going to use the work I've done in part A. So I'm going to rewrite this with the denominator changed to 9 root 7. Now here I need to rationalise the denominator. And I'm going to make my life a little bit easier here because I could times top and bottom by 9 root 7. But there's really no need, or what will happen is you'll end up having to do some calculations with a 9 instead. Root 7 will work just fine, as long as you deal with the rational bit. So the irrational bit, the root, it will work out nicely. So I'm going to put brackets around there as well, just so I don't forget that it's all of that multiplied by the root 7. That gives me 9 root 7 plus, and then the next bit I'm going to do it all in one go. I've got 3 root 7 times root 7. Well, root 7 times root 7 is 7, so I'm going to write that as 3 times 7 up there so you know what's happening. And then on the bottom I've got, again, root 7 times root 7, which is 7. So on the bottom I've got 9 times 7. That gives me 9 root 7 plus 21 all over 63. And I'm just going to simplify that a little bit. And I'm also going to split them up into 2 fractions because looking at the answer, that's the form that they want it in. So 21 over 63 is a third. So I've written this bit first because that's what they want here. 9 over 63 is a 7th. So we have a 7th root 7. Now the marks, you get 1 mark up here for replacing the denominator. You get 1 mark for trying to rationalise the denominator over here. And then there's 1 final accuracy mark there. Okay, question 2. Don't panic when you see a diagram that looks a little bit challenging. it normally means the question's easier, to be honest. That's what I find anyway. And I'm sure this paper is one that I used in your PPE exam. I certainly recognise a lot of the questions anyway, but it's good practice. So let's have a little look at this question first and see what we're dealing with. So we've got a triangle OBC and it's joined to a sector OAB with centre O. Okay, so what that means, and I'm not sure whether you realise, OA is going to be the same as OC, is going to be the same as OB. These are all the same because that's the centre of a circle. So these are all radii. So to work out, I don't know, I've changed colour. Let me go back to red. Right, so to work out OB, so that's this length here, I'm going to label it X. I can't use the cosine rule because I haven't got a kind of corner shape. So I can't use the cosine rule here. It does look like I can use the sine rule, but in order to use the sine rule, you need matching pairs. And I haven't got this matching pair. However, it certainly wouldn't be too difficult to work out that angle, would it? So that angle is 77 degrees. And now I have got 77. I have got matching pairs, so I can use the sine rule. I'm putting X on top rather than the angle on top, because then I haven't got to do too many rearrangements. So X over sine 50 equals 10 over sine 77. And then because X is on top, all you have to do is times by that sine 50 and make sure you are in degree mode. That comes out to be 7.86 centimetres. And the marks here, you get 1 mark for attempting to use a sine rule, so that's a method mark, so even if you make a mistake you will get a mark there, and then an accuracy mark. Okay, so that is part A. Now before we move on to part B, remember I mentioned that OB, OA and OC were all the same, so I'm just going to label all of these. So that is going to be 7.86. That is 7.86, and that's also 7.86. And that will be useful in part B. Okay, so part B. Find the length of the shaded region R. Okay, well, we know how to work out triangles. So we've got a triangle here, OAB. We've also got a sector. Okay, so if we're doing the sector, it's a quarter of a circle, and it's a quarter of a circle with radius 7.86. So the area of that sector there is going to be a quarter times by pi times by your r squared. And I have actually rounded this answer here, but if I was in the exam, I just stick that straight into my calculator later. Okay, now the triangle, so you've got that right angle triangle up here. So because it's a right angle triangle and I know the base and the height, I don't need to worry about using half AB sine C. I can just do half base times height. So it's a really lovely triangle. A half times base times height, which is the same, and I've just realised I've copied down my answers wrong, so just give me a second to change that. So the triangle is 30.905, the sector is 48.545 centimetres squared. I've got all of these written down ready and I've just done them in the wrong order. Okay, so I've got sector and I've got the triangle. Now I just need that bit up there, so I'm going to take them away from each other. So 48.545, take away 30.545, 0.905. I'm left with 17.64 centimetres squared as the area of my region. Area of region. And obviously, if this was in the exam, I wouldn't be writing in this bit here because it wouldn't get scanned. I have actually set it out a lot better in my own work. And what I might do is scan these for you anyway, so you've got a paper copy. But yeah, I haven't got much space here, so all of this was written out a lot neater down here. Okay, let me show you where the marks are awarded here. So you get 1 mark for trying to work out the area of a triangle. You may have made a mistake in that. 1 mark for the area of the sector, and then 1 mark for taking them away and getting your final answer down there. Okay, question 3. I've drawn a little diagram here that helps me. I'm not quite sure whether it will help you, but it certainly does help me. Because I find with vectors, trying to figure out the difference between position vectors and coordinates, and it's all a little bit confusing. So we've got A, B, C, which lie on a straight line. So I've got A and C, and B is the midpoint. Relative to a fixed point O, the position vector of A. So from the origin to A, that vector there is 5i minus 3j. So OA is 5i minus 3j. And we've been given the position vector of B as well. So that's O to B. So O to B is minus 2i plus j. Find the position vector of C. So the position vector of C is OC. So that's what we want, OC. But to work out OC, to get from O to C, we can go a different way. We can go along OA, we can go along AB, and then we can go along AB again because B is the midpoint. So if we know AB, we just need to double it. So the idea is to get from O to C, we're going to go along O to A and then twice A to B. But we're going to need to work out AB first. So AB, if we have a look at my diagram, A to B, I get from A to B by going back along OA and along OB. So A to B is negative OA plus O to B. So that is negative 5A plus 3j. So I've negated OA there. Plus OB, which is minus 2i plus j. That all simplifies down to minus 7i plus 4j. Okay, and you actually get 2 marks for that bit initially. So you get 1 mark for attempting to work out AB and 1 mark for doing it accurately. Now I've got that, I can work out O to C. So O to C is O to A and plus 2 lots of A to B. So O to A, 5i minus 3j plus 2 lots of A to B, minus 7i plus 4j. So that gives me 5i take away 14i and minus 3 plus an 8. Minus 9i plus 5j. And this is where your marks are awarded. You get 1 method mark for knowing to add on 2 lots of AB and an accuracy mark for the answer there. And then for part B, the distance. Well, to work out the distance, I'm just going to have to get rid of all this. The distance, remember, is the magnitude, so that's using a little bit of Pythagoras. So O to C, we worked out was minus 9i plus 5j. I want the magnitude of it, which is going to be the square root of the x component squared and then the y component squared. So we end up with root 106. You may have written it differently, that's fine. Root 106 is acceptable. You can simplify it down right as a decimal, that's acceptable too. It doesn't say in the question exact distance, so you can round it if you wish. Okay, and we get a method mark for attempting to do Pythagoras on it, accuracy mark for the answer. Okay, question 4. A lot to think about here. Big mark questions can be a bit overwhelming. So let's have a look and see what it's asking for first. So I normally read through and have a little look for hints. So it's talking about a tangent. So I want the equation of a tangent, which means I'm going to have to work out a point, and I'm also going to need a gradient. They've given us a curve here, and they've given us the x-coordinate, but they haven't given us the y-coordinate. So to do this bit first, the point, I'm going to work out the y value when x equals 1. So at x equals 1, y equals 1 squared, 3 take 1 equals 2. So I've now got my point. The point on that curve where the tangent is 1, 2. So that's my first bit done. Now I also need the gradient. So if I have a look at this, I haven't got 2 points, it's not a straight line. So I'm not going to be able to work out the gradient using changing y over changing x. So this is a differentiation question. And the y is not in the format that we can easily differentiate. So we're going to have to simplify that down a little bit first. So to work out the gradient, I'm going to expand that first, 3x squared minus x cubed, and the gradient is dy dx. Times by the power, power reduces by 1, times by the power, power reduces by 1. I want the equation of the tangent at the point when x equals 1. This, remember, gives me the gradient of the entire curve. So I want to know what is the gradient at the point x equals 1. So when x equals 1, the gradient is 6 times 1 minus 3 lots of 3 squared. The gradient is 3. And let me show you where some of the points are available here. You get a method mark for attempting to work out the derivative, and there may be a few mistakes in there, that's fine. You get an accuracy mark if you've done it perfectly. You also get a method mark for trying to work out the gradient at the point x equals 1, and 1 mark for doing it accurately. So what we've got so far is we've got a point, we've also now got a gradient. I'm going to use y minus y1 equals mx minus x1 because I don't want to have to faff around working out the constant. My point is 1, 2, my gradient is 3. Y minus 2 equals 3, x minus 1. It doesn't say, oh it does say, it says to give my answer in the form y equals mx plus c. Okay, so I just need to rearrange a little bit here. Y equals 3x minus 3 plus the 2, y equals 3x minus 1. That is the equation of the tangent. And let's see where the other marks are available. So we've got 4 so far. So we get 1 method mark for using this. It could be y equals mx plus c. It doesn't matter what you use. Okay? And you get an accuracy mark right there. So there's your first 6 marks. I'm going to stop the video now and upload this one. I'm going to do them in chunks just because it's quicker to upload for me. So there will be a second video starting from question 5.